Students in 11th standard 1.3 exercise introduction I'm going to give now. So here let we start with the functions. What do you mean by function? I will write a definition here. I wrote a definition. You check. Let A and B are the two sets. A and B are non-empty sets. A relation F. We will start with the relation. A relation F from A to B. So there is a relation. The particular condition satisfying A to B. So we know very well all the relation is a subset of Cartesian product of AB called function from A to B. It satisfied. So if satisfy the two conditions, then the relation F we can say it is a function. What is the first condition is given? For all A belongs to capital A. That is for every element a domain. So here A is a domain and B is a codomain. Every element a domain, there is a element B belongs to capital B. That is every element domain having a image in a codomain, which is if a set A contains 16 elements, 16 elements having a relation with the B set. So every element, that is every element domain having a image in a codomain. The next one, if A comma B belongs to F, the function, and A comma C is also belongs to F, then B and C are equal, which means if A related with B and A related with C also, then we can directly say B and C are not a different element, same elements, which means every element domain have a unique image in a codomain, which means each element domain having a unique image, not a two or more relation. So from the arrow diagram I am going to explain you. That is if A is a domain, if I am calling B is a codomain, A 1 2 3, then here 1 2 3 4, like that we have elements. Here I am defining a function F. A having a 1 having a relation with 1, if 2 have a relation with 2, then 3 have a relation with 3, then this is a function because every element have a image, then every element have a unique image, one having only one image. If one have another, if I'm telling one having a image 1 and one have another image is 4, then this is not a function, because each element having a unique image in a codomain. So very easy to understand. We are telling mom and son. So always we call this is a codomain as a mom and this is son. Each son having one mom from the codomain, correct? Then the particular son, how it will be exist two moms, so it is not existing. So easily we can understand if mom son. Another way we have to less than symbol if forming, it is not a function. Greater than symbol, it is a function. Like that is also easily we can understand. Again I will tell formally definition way. If for all A belongs to capital A, there is an element in a B. So every element domain having an image in a codomain. The next one, every element in a domain having a unique image in a codomain. Unique image. So there is no two image for the same element domain. Okay. So this is a definition of the function. So we representation of function, we know very well, represent tabular form, like that we represent the function. 10th standard itself we studied x and f, 1 2 3 4 5 6, like that we represent. This is a tabular form representation. Then graphical form, last year itself we studied graphical representation also we studied. This is called arrow diagram, the representation of function in arrow diagram. Then we study set of ordered pair. Like this also we can represent a function. Like this also we can represent. See, this is a set of ordered pairs. So function can represent by tabular form, graphical form, then arrow diagram method to explaining the function, or set of ordered pair. This is also representation of the function. Now I am going to tell about vertical line test, but we studied in it 10th standard itself vertical line test. See, this is the test is useful to us to check whether the function or not. If the function given by graphical, if I am going to draw one graphical form of function, for example this is a function, graphically they represent the relation. If I'm here, I can draw any vertical line at any point. If I can draw any point, we can draw vertical line. It should cut the curve at exactly one point, then we can say it is a function. You understood? If I am going to draw a line, vertical line to the graph, it's intersect exactly one point, then we can say it is a function. It is function. Okay, when we say it is a function, if I any point, this is your wish to draw a line. Okay, any section we can draw a vertical line. If we intersect the curve, not a horizontal axis, vertical line, it cuts the curve at exactly one point, then we say it is a function. For example, I am going to draw another curve. This is a famous parabolic curve. Whether it is a function or not, while I am drawing a vertical line, it will intersect two points at the curve, so then we say it is not a function. So parabolic curve is not a function. So this type of testing is called a vertical line test. Okay, now I am going to tell about some elementary functions. So you take your book and just you read one time. I am giving explanation for that. You can take your book and underline it, what are the points I am giving. First we are going to enter some elementary function. In that, identity function. What do you mean by identity function? Identity function is nothing but domain. See, if I am telling A, B, C, then here we have A, B, C, D. If A mapping to A only, B mapping to B, and C mapping to C, here not A. Okay. So each element in a domain map to same element, then we say it is a identity function. Let X be a non-empty set, then f of x equal to x, which means the function does not change the value. If I am putting x equal to 1, f of 1 is also 1. So this is 1 comma 1 will get. If I am putting x equal to 2, f of 2 equal to, substitute x equal to 2, then 2 comma 2. This type of element related with the same element, then you say it is a identity mapping or identity function. You understood what I mean by identity function? Identity function is nothing but f of x equal to x or y equal to x, which means every element and domain mapping with the same element to codomain. Here domain and codomain are same set, a to a, x to x, b to b, like that. Next I am going to tell about constant function. For example, there is a domain a, b, c, the another one is a codomain x, y, z. Every element mapping to the same constant number, then is called a constant function. So this is called a constant function. For example, f of x equal to 3. See, if I am putting x value any, if x equal to 1, the function value does not change, that is 1 comma 3. If I am putting x equal to 2, then also the function value f of 2 equal to 3 only, 2 comma 3. So if I draw the diagram, we will get, for example, AB 1 2 3 4, here 1 2 3 4, like that. Every element is mapping to 3 only. So this type of function is called a constant function. What a constant function. Then next modular function or absolute function. Modulus function. Modulus function is nothing but f of x equal to modulus of x. If I am substituting any value for x, it is become positive. That is called a modulus function. We know very well modulus of x is minus x if x less than 0, if x greater than 0. which mean if I'm drawing a curve, we will get a like that. If I'm putting 1, then we will get 1 only. If I'm putting minus 1 also, we will get 1. If I'm putting 2, the answer will be 2. If I'm substituting minus 2 also, we will get minus 2. Like that, the diagram should be like that. So it is called modular function. If I'm substituting negative also, it become a positive. It is called modulus function or absolute function. Okay students, now we will start one-to-one function. Then what I mean by one-to-one function? See, the quite difference from function and one-to-one function, because in a function I said every element in a domain having a unique image in a codomain. But this one is a different. If a function f from a to b is said to be one-to-one, two elements from a set A, if it is not equal, the function value is also not equal. If if two elements I am taking from a set A, these two are not equal. For example, 1 and 2, these two are not equal. The function's value is also not equal. Or if two functions value are equal, then the value is also equal. Domain elements also equal. Quite we have to understand what I mean by one-to-one function. I am going to draw the graph to explain it. For example, A and B. A, B, C and X, Y, Z. A mapping with X and B mapping with Y and C mapping is also with Y. So see the difference. It is a function because every element domain having a image in a codomain. Every element domain having a unique image. C having a Y. There is no image for C. B having image Y. There is no different image for B. It is a function because the mom and son. If I am son, see X having a son A, Y have two sons B, C. Yes, it is a possible to say, but it is not a one-to-one function because if B and C are different elements, correct? B is not equal to C. What is the function of B? Function of B is Y. What is the function of C? Function of C is the function of C is what? That is also Y. So if B is not equal to the function value it is satisfy condition equal. So it is not a one-to-one function. And again I will tell, if two elements are different in a domain, the image is also different in a codomain, then only we say it is a one-to-one function. Again I will tell, different element domain having a different image in a codomain, then only we say it is a function. Or same, that's all. This is a quite understandable explanation, I think so. Different element domain, that's all I am putting not equal. Different element domain having a different, this is saying it's equal, which means this is not a function. If C connect with Z, then we say it is a function because B value Y, function value Y, and C function value Z, then these two also not equal. So that is a one-to-one function. What do I mean by one-to-one function? Different element domain have different images in a codomain, or same solutions exist, then the domain also is equal. The first one is a more understandable one. A different element domain having a different images in a codomain. Next we will go for onto function. What do I mean by onto function? For each B belongs to capital B, this is codomain element. Every codomain element have a pre-image with domain. That is, if I am going to draw one X and Y, A, B, C, then X, Y, for example. A connect with A and B, C also connect with Y. So it is onto function. Sorry, onto function. What do you mean by onto function? Every element in a codomain, having image with pre-image in a domain. So range equal to codomain. Easily we can understand. What do you mean by range? What are the values are connecting with the codomain elements is called range. So every element in a codomain having a pre-image in a domain, that is called onto function. Again I will tell what I mean by onto function. Every element in a codomain there exists at least one element in a domain, that is called pre-image. So every element in a codomain have a pre-image in a domain, so that is called onto function. So I explained onto function. See, if only one to one only satisfied, then is called injective. If the function satisfy only onto is called surjective. If the function satisfy one to one and onto the both, we can say it is a bijective function. That and all we studied in a 10th standard itself. Again you have to underline it in your book and read carefully. Thank you, students.